Hey everyone, how are you all doing? Well, in today's video, let's discuss the 5 most important 4 markers. Let's begin. If A is equal to cos x sin x minus sin x cos x, then show that A into A transpose is equal to A transpose A equals to 1. Alright. Fine, let us first take the transpose of A. What is A transpose over here? A transpose will be cos x sin x minus sin x cos x. This is the transpose of A. Now let's perform A into A transpose. Alright, so it's gonna be A into A transpose is equal to cos x sin x minus sin x cos x into what is A transpose? A transpose will be cos x sin x minus sin x cos x. Alright, now let's multiply them. Take the first row, multiply with the 2 columns of the second matrix. That is gonna be cos x into cos x plus sin x into sin x. This will be my first element. My second element is going to be with the second column. Alright. So that is going to be cos x into minus sin x plus sin x into cos x. Well, let me shift this to the top. Fine. Now let's take the second row and the 2 columns. Alright. Now minus sin x into cos x plus cos x into sin x. Then this will be my third element. Then fourth element will be second row and second column. That is gonna be minus sin x into minus sin x plus cos x into cos x. Alright. What is this equal to? Here we are gonna have cos square x plus sin square x, isn't it? Now here this is going to be cos x, or I can write it as minus cos x sin x plus sin x cos x. Alright, then here I am going to have minus sin x cos x plus sin x cos x. Then my fourth element will be sin square x plus cos square x. This is cos square x. Alright, if you observe over here, look at the second element. Minus cos x sin x plus cos x sin x will be 0. Again, the third element will also be equal to 0. If you look over here, cos square x plus sin square x. Cos square x plus sin square x. What is this equal to? Well, we have studied that sin square x or sin square theta plus cos square theta is equal to 1, isn't it? Now let's substitute 1 in the place of sin square x plus cos square x. Now let's simply erase this and write down 1 over here. And this can also be replaced by 1. And can I delete all this and write down 0? Well, I can delete them, right? So here I'm going to have 0 and 0. Let's not make it very complex. Let's just short it down. Here, my matrix is going to be 1, 0, 1, 0. As simple as that. Sorry, it's going to be 1, 0, 0, 1. Right? So 1, 0, 0, 1. Alright, if you look at this matrix, the diagonal elements are all 1 and the rest of the elements are 0. Right? Such a matrix is known as a unit matrix, isn't it? So can I simply write this entire matrix as 1? I can do that. So that is what is the value of A into A transpose, where we prove that it is equal to 1. Now let's prove that A transpose into A is equal to 1. So A transpose A is equal to, let's write down A transpose over here. It's gonna be cos x sin x minus sin x cos x into cos x minus sin x cos x. Alright, now let's simply multiply them. Take the first row. We have cos x minus sin x with the two columns of the second matrix. What is that going to be equated to? Let's see over here. Cos x into cos x plus minus sin x into minus sin x. Look at the values carefully, right? Alright, this will be my first element. My second element is going to be with the second column, right? Well, this is gonna be cos x into cos x plus, sorry, this is gonna be cos x into sin x. Here we have sin x, right? So cos x into sin x plus minus sin x into cos x. Alright. Moving ahead, we have the second row with the two columns again. So sin x into cos x plus cos x into minus sin x. Fine. Then the second column, that is going to be sin x into sin x plus cos x into cos x. Alright, these are my four elements. Now let me try to simplify them. Now if you look over here, firstly I have cos square x plus sin square x. That will be equal to 1. And if you look over here again, sin square x plus cos square x, it will be 1 again. If you look over here, it will be sin x cos x minus sin x cos x. That will be equal to 0. Again the same over here, sin x cos x minus sin x cos x. That will be 0. So my new matrix will have 1, 0, 0, 1. This is simply a unit matrix or an identity matrix that will be equal to 1. So hence proved. Now if you look at this question, you're being given with two matrices A and B. You got to find out AB and BA. Well, it seems to be like an ordinary everyday question, but it is not. If you look at this matrix A, it is of the order 3 by 3. And matrix B is of the order 3 by 2. Now, how do you multiply these matrices? Before I tell you how to multiply, let me tell you, here it is of the order 3 by 3 and here it is of the order 3 by 2. Let us learn one concept over here. Alright. You can only multiply when you have such orders. Let me tell you which orders you can multiply. If you look at the interior terms. Now when I am talking about interior and exterior, here let me make out the concept clear. Alright. Interior terms are these two terms. These two are interior terms. On the other hand, these two terms over the extreme ends, they are the exterior terms. Fine. Now, well, for multiplication, the interior terms must be equal. Alright, that means here we have 3 and 3 equal. And that is when A and B can be multiplied in fact. Alright, that is when multiplication of A and B would be possible. And one more thing that you got to learn over here is whatever the exterior terms are there, that is 3 and 2. Okay, these are the exterior terms. The output of the multiplication of 3 by 3 and 3 by 2 will give you a matrix which has the order 3 by 2. Fine. Now, what if I say multiply B and A, that is B into A. That is, we already have a question. In the question, we are asked to have multiplication of B and A. Now, do you think the multiplication of B and A would be possible? Let me show you. B and A will be equal to the order 3 by 2 into, let me show, 3 by 2 into 3 by 3. Now, if you look at their interior terms, are they equal? They are not equal. So, multiplication is not possible. So, B into A will be undefined. Okay, this is the concept that you need to be aware of. Alright. Now, let's multiply A, B. How do we do that? Let me show you. Now, AB will be equal to 0, 1, 2, 1, 2, 3, 2, 3, 4 into, let's multiply with B, 1 minus 1, 2, minus 2, 0, minus 1. Come on, let's take the first row, multiply with the two columns. Remember that concept is the same, alright? Now, take the first row, 0 into 1, take the first column as well, yeah? So, 0 into 1 plus 1 into minus 1 plus 2 into 2. Put this aside. Take the second column. Let's be quicker, right? So, this is the second column. 0 into minus 2 plus 1 into 0 plus 2 into minus 1. Fine. Take the second row. Multiply with the two columns. What is that going to be equal to? 1 into 1 plus 2 into minus 1 plus 3 into 2. Then the second, that is going to be equal to 1 into minus 2 plus 2 into 0 plus 3 into minus 1. Alright. Take the third row. Here we have the third row with two columns again. That is going to be 2 into 1 plus 3 into minus 1 plus 4 into 2. Then with the second column, 2 into minus 2 plus 3 into 0 plus 4 into minus 1. Now let's solve them. Here we have the output answer, which is of the order 3 by 2. You remember? So here we are going to have 0 minus 1 plus 4. 0 minus 1 plus 4, that will be 3. So here our first element is 3. Then secondly, we have this, right? So this is 0 plus 0 minus 2. What is it? Minus 2, isn't it? Alright, moving to the second row. We have 1 minus 2 plus 5. What is this? Hold on. What is 3 times 2? It is 6. So this is 6. So this is basically 1 plus 4, that is 5. Here you're going to have 5. Then take this element. Let us delete this all. Take this one. What is this? This is going to be minus 2 plus 0 minus 3. This is going to be minus 5. So here you're going to have minus 5. Take this one right now. 2 minus 3 plus 8. What is this going to be equal to? 2 plus 5, that is 7. So here we'll have 7. Then take this one. Minus 4 plus 0 0 minus 4. Right? Hold on. Haha. So what is this? Minus 8. So here you're going to have minus 8. Now what is this? This is basically A times B. Okay. This is equal to AB. And of course, we already discussed that B into A is not possible. Alright. Or you can simply say B into A would be an undefined answer, since the number of the column of B is not equal to the number of the rows of A. BA is not defined. Thirdly, we have two matrices of the same order 3 by 3. They are asking us to examine whether A and B commute with respect to the multiplication of matrices. Now what does that mean? Well, what is the commutative property? It is basically A into B is equal to B into A, when we have learned this in the lower grades. But does that imply to the multiplication of matrices? Well, we're going to show if AB is or not equal to BA. Alright, that is what they are asking. If it is equal, show it. If it's not equal, show it. Well, it will not be equal. Alright. So let's solve AB and BA and then show them that they are not equal. Alright. So the commutative property does not imply to the matrices. Here they are of the order 3 by 3. 3 by 3. The interior terms are equal. So multiplication will be possible. And the output answer will be of the matrix 3 by 3. That is the exterior terms. So multiplication is certainly possible if you're thinking that it's not. Alright. So let us first take AB will be equal to 1. AB is equal to matrix A into matrix B. Now the same concept, take the first row, multiply with the 3 columns. That will be 1 into 1. Take the first column, isn't it? So 1 into 1 plus minus 2 into 0 plus 3 into 1. Fine. What will this be equal to? Here we have 1 plus 0 plus 3, that is 4. So instead of writing all this, I am putting on 4 over here. Alright. Then I am taking the column 2. So that is going to be 1 into 0 plus minus 2 into 1 plus 3 into 2. So this is going to be 0 minus 2 plus 6. This is 4. So here again I'm going to have 4. Moving to the third column, we have 1 into 2, 1 into 2 plus minus 2 into 2 plus 0 into 3 or 3 into 0. What will this be equal to? Well, here you have 2 minus 4 plus 0. This is minus 2. So here you will be having minus 2. Now let's take the second row with the first column. Alright. So that is going to be 2 into 1 plus 3 into 0 plus minus 1 into 1. Fine. This is equal to 2 plus 0 minus 1. That is equal to 1. So here we'll be having 1. Moving forward, we have the second column. That is going to be 2 into 0 plus 3 into 1 plus 2 into minus 1 or minus 1 into 2. Alright, what is this equal to? 0 plus 3 minus 2. This is 1 again. So here we'll be having 1. Now with the third column we have 2 into 2 plus 3 into 2 plus minus 1 into 0. What is this going to be equal to? 4 plus 6 plus 0, that is 10. So here we'll be having 10. Now the third row with the first column, so it is minus 3 into 1 plus 1 into 0 plus 2 into 1. This is minus 3 plus 0 plus 2. Minus 3 plus 2, that is minus 1. Fine, so here it's gonna be minus 1. Now with the second column, that will be minus 3 into 0 plus 1 into 1 plus 2 into 2. This is 0 plus 1 plus 4, that is 5. Here we are having 5. Finally, the third row with the third column, that is minus 3 into 2 plus 1 into 2 plus 2 into 0. Alright, that is going to be minus 6 plus 2 plus 0. That is minus 4. So here we're going to have minus 4. Now this is A into B. Let's note this down. In the next slide, we're going to solve what BA will be equal to, and let's see if these two are equal. Certainly they'll not be equal. We'll be proving that. Now let's take B into A. Alright, take the first row with the first column, that will be 1 into 1 plus 0 into 2 plus 2 into minus 3. This is 1 plus 0 minus 6, that is minus 5. Here let's write down minus 5. Fine. Now let's take the first row with the second column. That will be 1 into minus 2 plus 0 into 3 plus 2 into 1. What is this? Minus 2 plus 0 plus 2. That is minus 2 plus 2 is 0, isn't it? So here we're going to have 0. Now first row with third column, 1 into 3 plus 0 into minus 1 plus 2 into 2. What is this going to be equal to? 3 plus 0 plus 4, that is 7. Let's write down 7 over here. Second row with first column now. 0 into 1 plus 1 into 2 plus 2 into minus 3. This is 0 plus 2 minus 6, that is minus 4. So here let's write down minus 4. Now second row with second column, that will be 0 into 2 plus 1 into 3 plus 2 into 1. This is 0 plus 3 plus 2, that is 5. Now second row with third column will have 0 into 3 plus 1 into minus 1 plus 2 into 2. Here 0 minus 1 plus 4, that is 3. So here let's write down 3. Third row with first column now. 1 into 1 plus 2 into 2 plus 0 into minus 3. This is 1 plus 4 plus 0, that is 5. Here we're going to have 5. Then we have the third row with the second column, that is 1 into minus 2 plus 2 into 3 plus 0 into 1. What is this equal to? Minus 2 plus 6 plus 0. This is 4. So here we're going to have 4. Then lastly, third row with third column, that will be 1 into 3 plus 2 into minus 1 plus 0 into 2. Here we have 3 minus 2, that is 1. So 3 minus 2 plus 0, that will be 1. So here let's write down 1. So here have a look at AB and BA. If you look at them, they are not equal, right? Since they are not equal, therefore A and B do not commute with respect to the multiplication of matrices. Here we have the fourth question on our screens. Here we are being given with one matrix where we're going to show a square minus 4a minus 5 1 is equal to 0. Here 1 is the unit matrix. Alright, so here Let's try to prove it equal to 0. Firstly, let's bring on a square. Take the first row with the first column, that will be equal to 1 matrix, isn't it? Let's draw the matrix. Alright. 1 into 1 plus 2 into 2 plus 2 into 2. What is this equal to? 1 plus 4 plus 4, that is 9. So here we're going to have 9. Then with the second column. So this will be replaced with the second column. Here we are having 1 into 2 plus 2 into 1 plus 2 into 2. What is this equal to? 2 plus 2 plus 4, 8. So here you're going to have 8. Then with the third column, it will be 1 into 2 plus 2 into 2 plus 2 into 1. This is 2 plus 4 plus 2, isn't it? This is equal to 8. So again, we are going to have 8 over here. Now take the second row with the first column. You'll have 2 into 1 plus 1 into 2 plus 2 into 2. This is equal to 2 plus 2 plus 4. That is equal to 8. So here you're going to have 8. Then with the second column, we'll have 2 into 2 plus 1 into 1 plus 2 into 2. What is this equal to? 4 plus 1 plus 4. That is equal to 9. Then with the third column, that will be equal to 2 into 2 plus 1 into 2 plus 2 into 1. That is 4 plus 2 plus 2, that is 8. So here we'll have 9 and 8. Now the third row with the first column, you'll have 2 into 1 plus 2 into 2 plus 1 into 2. What is this equal to? 2 plus 4 plus 2. Again you'll have 8 over here. Then with the second column, that will be 2 into 2 plus 2 into 1 plus 1 into 2. This is 4 plus 2 plus 2. Again 8. Then with the third column, alright, here you're going to have 2 into 2 plus 2 into 2 plus 1 into 1. This is 4 plus 4 plus 1, that is 9. So this right over here is a square. Now let's quickly find out 4a. Now 4a will be equal to 4 into matrix A. That means 4 is going to be multiplied with every element in the matrix in this manner. What will this be equal to? 4, 8, 8, 8, 4, 8, 8, 8, 4. Now let's find out 5 into 1. That is 5 into matrix, unit matrix actually, right? What is unit matrix? The diagonal elements should be 1. The rest of the elements will be 0. So here 5 must be multiplied with every element right now. What will this be equal to? 5, 0, 0, 0, 5, 0, 0, 0, 5. Now that we got all the values, let's subtract them one by one. Now let's subtract them. 9 minus 4 minus 5. 9 minus 4 is 5. 5 minus 5 is 0. Alright, let's put on 0 over here. Now 8 minus 8 minus 0. That is 0 again. 8 minus 8 minus 0. That is 0 again. Alright. Now the second rows. 8 minus 8 minus 0. Isn't it 0? Then 9 minus 4 is 5. 5 minus 5 is 0 again. Alright. Then 8 minus 8 is 0. Minus 0 again 0. Now the third row. 8 minus 8 minus 0 0. 8 minus 8 minus 0 0. Alright. Then we have 9 minus 4 5. 5 minus 5 0. All of these are equal to 0. Hence this is completely equal to 0. Hence proved. Moving forward, we are being given with two matrices A and B. They are asking if AB and BA exist. If they exist, then you got to find them. do A and B commute with respect to multiplication? Alright. So firstly, we are going to check if AB and BA exist. Alright. What is the order of A? The order of A is 2 into 3. Rows into columns, isn't it? So 2 into 3 will be the order of A. Then what is the order of B? The order of B is 3 into 2. Now 2 into 3, 3 into 2. If you look at their interiors, right, aren't they same? They are same. So multiplication of AB will be possible. Alright. And their output order will be 2 by 2. Fine, that is about AB. Now if I have to talk about BA, that will be 3 by 2 and 2 by 3. Now if you look their interiors, they are same, so multiplication is possible, and their output answer will be of the order 3 by 3. Fine, so AB and BA exist. Now if they exist, find them. So you're simply going to find out AB and BA. Then the next part of the question says, do A and B commute with respect to multiplication? That means, will AB equal to BA? That is what they are asking. Alright. So once you find out AB and BA, you're going to check if they are equal. Alright. Now let's quickly find out AB. Take the first row. With the first column, you'll have 1 into 2 plus minus 2 into 4 plus 3 into 2. Alright, what will this be equal to? 2 minus 8 plus 6. So 2 minus 2, that is 0. So here you're going to have 0. Then with the second column, you'll have 1 into 3 plus minus 2 into 5 plus 3 into 1. This will be 3 minus 10 plus 3. Alright, so that is 6 minus 10, that is minus 4. So here you'll be having minus 4. Now second row, with the first column, you'll have minus 4 into 2 plus 2 into 4 plus 5 into 2. This will be minus 8 plus 8 plus 10. That will be equal to 10. So here you're going to have. Now with the second column, that will be minus 4 into 3 plus 2 into 5 plus 5 into 1. That will be minus 12 plus 10 plus 5. That is minus 2 plus 5, that is 3. So here you're going to have 3. Now this is AB. Let's note it down and find out BA next. Now BA is equal to 242,351 into 1 minus 2, 3 minus 4, 2, 5. Fine. Now take the first row. With the first column, that will be 2, 3 and 1 minus 4. That is 2 into 1 plus 3 into minus 4. That is 2 minus 12. That is equal to minus 10. So here you're going to have minus 10. Now with the second column, that is going to be 2 into minus 2 plus 3 into 2. This is minus 4 plus 6, that is 2. So here you're going to have 2. Now with the third column, that will be 2 into 3 plus 3 into 5. That is 6 plus 15, that is 21. So here it will be 21. Second row, with the first column, it is 4 into 1 plus 5 into minus 4. That is 4 minus 20 minus 16. Alright. Then take the second column. 4 into minus 2 plus 5 into 2. What is this? Minus 8 plus 10, that is 2. So here you're going to have 2. Now with the third column, 4 into 3 plus 5 into 5. That is 25 plus 12, that is 37. So here you're going to have 37. Now the third row, with the first column, 2 into 1 plus 1 into minus 4. That is 2 minus 4, that is minus 2. Now the third row with the second column, 2 into minus 2 plus 1 into 2. Minus 4 plus 2, that is minus 2. Again we're going to have minus 2. Then with the last column, we are having 3, 5. Alright, so let me highlight this. Yes. So 2 into 3 plus 1 into 5. That is 6 plus 5, that is 11. So here you're going to have 11. Now have a look at AB and BA. Are they equal? They are not equal. So AB and BA do not commute with respect to multiplication. Well, that's the end of today's video. Make sure you hit the like button, share and subscribe. Thank you.